the ellipse becomes more nearly circular. If they're moved farther apart, the ellipse becomes more flattened. The longest distance across the ellipse, which passes through both foci, is called the major axis. The shortest distance across the ellipse, passing through the ellipse's center, is called the minor axis. The semi-major axis is half the major axis, and the semi-minor axis is half the minor axis. The eccentricity of the ellipse is the distance between the foci divided by the length of the major axis. If the foci coincide, then E is equal to 0, that is the eccentricity, and the ellipse is a circle. The other limiting case, E equals 1, represents the case in which the foci are separated by the full length of the string. It was quite a feat for Kepler to discover the elliptical shape of planetary orbits, since most planets have orbits with small eccentricity. Of the planets known to Kepler, Mercury had the largest eccentricity of E equals 0.21. All the others had E less than 0.1. Yes! Johannes Kepler. Wow! So that was the first law. Let's say the first law again. Planets travel on elliptical orbits with the sun at one focus. That's the first law, and then we talked about what an ellipse is. So, done with that first law. Second law! Kepler's second law. Aww, my little Kepler. Second law, a line drawn from the sun to a planet sweeps out equal areas in equal time intervals. Wow. This law provides a quantitative description of how the orbital speed of planets changes with their distance from the sun. Not only is motion not circular, Kepler discovered, it doesn't have uniform speed either. The second law is graphically demonstrated in figure 2.18. We'll look at it in just a second. A mythical planet has its motion plotted during 2 time intervals, each 10 days long, separated by half the planet's orbital period. The 2 wedge-shaped areas swept out by the planet-sun line are of equal area, even though they're of different shape. Kepler's second law implies that planets move most rapidly at perihelion, the point on their orbit closest to the sun, and least rapidly at aphelion, the point farthest from the sun. Let's look at the picture. Here it is, equal areas in equal time intervals. So, line drawn from the sun to a planet sweeps out equal areas in equal time intervals. That's the second law. And we looked at it just now. Only thing saving us is McDonald's. On Mars? Yes, are you gonna put McDonald's on Mars? Kepler's third law. The squares of the sidereal orbital periods of the planets are proportional to the cubes of the semi-major axis of their orbits. Yeah, no, Kepler really was. Kepler was awesome. Yes, Goodwill. Agreed. Because look at all this work he did. Dora, what's your favorite fast food? People really like McDonald's in the US, man. Us Belgians wouldn't know. I'm from Belgium, so I don't really know. But Americans, they love McDonald's.